So welcome to this introduction on the SAP Cloud Platform ABAP environment and the ABAP RESTful application programming model. And I just want to take a couple minutes and give a little bit of an overview of both of these topics. We'll start with the SAP Cloud Platform ABAP environment. So the SAP Cloud Platform ABAP environment, also known as Steampunk, um, we now offer the ABAP capabilities as a service in the SAP Cloud Platform. With this, we get HTTP services, so the ability to call external HTTP APIs from ABAP, as well as we have the ability to expose HTTP services as well. We have the new ABAP RESTful programming model, which helps developers create full-blown applications quickly, leveraging core data services or CDS. Um, Important to mention that this is a cloud-optimized ABAP language in Steampunk. And what this means is this is a nice way of saying that you don't have all of the ABAP features and facets that an ABAP developer might be used to and might expect to have here. For example, since there's no SAP GUI support here, statements that have to do with list processing or DIN-pros or web DIN-pros, none of those types of statements are supported here. Also, many APIs that you might be used to using in your day-to-day development, um, many of those APIs might not be whitelisted. Um, but there are new APIs that in some cases replace those ones that perhaps aren't whitelisted. Um, we use ABAP development tools and Eclipse as our IDE here. Again, no access to the SAP GUI, so we're not doing development in SE80. We'll also use Git. Git is another important aspect here. We use ABAP Git to manage our repositories objects as well. Now, with ABAP in the SAP Cloud Platform, we have the ability to create, again, our full-blown applications standalone. But we also have the ability to connect to other cloud and on-prem systems via communication scenarios, which allows us to extend functionality, for example, to an on-prem S/4HANA system without actually having to touch the core. Okay, so let's move forward and talk about the ABAP RESTful application programming model. So let's talk a little bit about the evolution of the ABAP programming model itself. So versions previous to ABAP 7.5 includes classical programming concepts, so our reports, DIN-Pro, Web DIN-Pro, Floor Plan Manager, things like that. This was the foundation of the business suite applications. And then ABAP 7.5 is the foundation underneath the first on-prem delivery of S/4HANA. We introduced the ABAP programming model for SAP Fiori, leveraging existing ABAP language and tooling, but also building upon it with tooling around OData, for example, transaction SEGW or our gateway services, allowing you to expose your data using OData. This programming model is based on CDS, Core Data Services, very important technology, allowing you to define views or a data model and association between those views. This allows us to define aspects of the user interface as well. HANA has its own flavor of CDS as well. It's a little bit different than the CDS that's in ABAP. For transactional handling here, we're also using a lightweight version of the business object framework. Now we come to the ABAP RESTful application programming model, which we've introduced as part of the SAP Cloud Platform ABAP environment. So we did the cloud first shipment, and then in the release 1909, we shipped it on the on-prem version as well. This is clearly the direction and investment when it comes to ABAP for the future. Um, as you can see, this is also based on CDS, but we have some new artifacts such as behavior definitions, behavior implementations, service definitions, things like that. This allows us to define and implement our behaviors of our business objects using the ABAP language, and no separate frameworks is needed. So some key players in the RESTful application programming model. Firstly, again, the ABAP development tools in Eclipse. This is the IDE for the ABAP RESTful programming model, so we cannot use SE80 and the SAP GUI to create these types of applications. The new concepts and artifacts are only supported in ABAP development tools in Eclipse. The main languages here, again, CDS language as well as the ABAP language. CDS to define the data model and associations and the UI annotations, and ABAP to implement the behaviors. So behaviors for things like the create, update, and delete operations. And then also the underlying frameworks and application infrastructure allows the developer to really focus on the business rather, or the business logic rather than the underlying protocols. Okay, so we're getting into the weeds here when it comes to the ABAP RESTful application programming model. We have three main layers here. The first one being the data modeling and behavior layer, where we define the data model itself, the monolithic business object, where we define our views, our view definitions, and our behaviors. And then in the next layer is the business services layer, where we define our projection or our consumption views over the monolithic data model underneath. For example, if we wanted to filter various columns or behaviors from the underlying data model there. We also define the service definition, which exposes specific entities of our data model. And then the definition at this point is still protocol agnostic. So now we can create the service binding over top of that service definition, where we define the actual protocol, whether it be OData v2 or web API. And then the final layer is the service consumption layer, where we consume our service from SAP Fiori or as a web API. Okay, so let's go a little deeper into the business objects. So what is a business object? So first, again, it is our data model. The structure of our data model is a composition tree, which includes one root and then parent and child relationships to lower level nodes. And this is all defined in core data services. Okay. We have our behavior, where we implement the ABAP code for our create, update, and delete operations, as well as managing locks on the business object. Feature control is a way to influence the appearance of fields or operations. For example, disabling and enabling operations, or making fields read-only. Doing this either statically or programmatically. So for example, if a user is a manager, he should be able to edit the business object, while other users might only have display only or things like that. And then lastly, the runtime implementation here. From a conceptual point of view, the interaction phase, you write to the transaction buffer. and only actually save to the database during the save sequence. This is another view of the implementation types. We have the interaction phase where we have the modify, read, and lock. We see the flow into the transaction buffer, and then we see the save sequence where these methods are called by the framework, and we implement which are then implemented by the developer to update the data model directly. So what is the developer responsible for? Well, we have two scenarios. One is unmanaged and the other is managed. So in the unmanaged scenario, which is the brownfield development, where we have existing code that we need to leverage. In that case, all of the implementation of the create, update, and delete operations is purely on the responsibility of the developer, as well as the save sequence. In the managed scenario, or for greenfield development, the basic create, update, and delete operations and locking and things like that are all handled for you by the framework. So you don't have to do any additional coding to get those types of operations out of the box. Now, if you have custom actions or validations that you want to do, those types of things would need to be coded for by the developer. So a closer look at the unmanaged, we have our existing code that we want to leverage. The developer is responsible for the actual runtime and transaction buffer. In some cases, we may need to create some adapter classes in order to embed the code into the infrastructure. So, like for example, say your existing code might use some function module or class methods that return messaging in a certain way. Well, the wrap infrastructure expects it a certain way as well, and sometimes you may need to adapt whatever's coming back from your function module or classes to the way the wrap infrastructure expects it to consume it. So in that case, we would need some sort of adapter classes. But again, all of the implementation aspects of your application are the responsibility of the developer in the unmanaged implementation. For the managed implementation, the entire runtime is managed by the underlying framework itself. So basically, the create, update, and delete type operations, again, are handled for you, and you only are responsible for the extra validation type implementations or custom actions. So then we have a scenario where we have a hybrid approach, or a mixed scenario where we have a managed implementation with some unmanaged application components. So let's say that we don't have any interaction coding, but we have coding that we need to implement for the save sequence. So the developer has access to the save task where he can sort of hijack the save sequence and write his additional logic during the save sequence. So basically having the create, update, and delete handled it in the interaction phase, but being able to override the save sequence and do some additional processing that's necessary. Okay, this is what our development flow looks like at the moment. So we're just talking about this lower level here where we're creating our data model, we're adding behaviors, and we're implementing our behaviors. Now, at the business services layer, this is where we create our service definition and expose the specific entities. The service binding itself is where the protocol is defined, as well as the scenario. In the case of a UI, this will give us the ability to have a Fiori elements preview. And for like a web API, we have the ability to do a Swagger UI preview as well. So adding on top of our development flow, uh, we have our data mono projection or our consumption views at the next layer above our monolithic layer. So again, this projection layer or consumption layer is where we are further filtering our monolithic layer or business object layer for our specific needs. So again, let's say that we have a scenario where our monolithic business object layer is purchase order, okay? And then at a higher projection or consumption layer, we want to filter that by what can be done by a manager or what can be done by a purchasing clerk, right? In the case of the manager, they probably have more rights to do different operations, and that's where we would implement that type of logic, where we're going to filter the the available operations or data that's exposed via a consumption or projection view, as well as a behavior projection, where the purchasing clerk may not have the ability to, for example, delete purchase orders or something like that. Okay, that's what we're doing at that projection and consumption layer. And then on top of that, we see the service definition, where then we expose the entities of our projection or consumption layer. Instead of exposing directly our monolithic business object layer, we are only exposing our projection or consumption layer. And then on top of our service definition, again, we have that service binding, which leads us to our preview. So that was just a quick overview of the SAP Cloud Platform ABAP environment and the ABAP RESTful application programming model. Now it's time to get into the system and do a couple of exercises where you can expand your knowledge and dig deep into these concepts.